Cool. Is this working? Yeah, good. Also, thank you very much for having me here. It's kind of a pleasure to be back, though I was here somewhat recently, so it's not as big a deal. But thank you. It's been SEPA is a great place, and it's nice to revisit. So the paper that I'll be talking about today is looking at academic inequality, but outside of a test score space. And so we're going to be using data from the Civil Rights Data Collection. So there's this old sociological question about the relationship between schooling and inequality. And one of the predominant figures or theorists that casts a very long shadow over this question is Coleman, who has this view that schools don't really do that much. They don't really mediate this relationship. So in their report, they have this famous quotation: schools bring little influence to bear on a child's achievement that is independent of his background and general social context. Inequalities imposed on children by their home, neighborhood, and peer environment are carried along to become the inequalities they confront at the end of school. This is kind of one of the main theories that comes in the sociology of education. And so in work that I've done with Sean and Dimitri Kalogridis, we kind of basically are able to confirm this basic finding. So on the y-axis here are test score gaps among black and white students. Each dot is a school district. The size of the dot is about the enrollment of the district. And you can see here that on the x-axis is a measure of the socioeconomic disparity at the district level. And you see these really sizable correlations, a 0.42 correlation here in just a simple bivariate relationship. When you look at our preferred measure of segregation, which captures the differential exposure to school-level poverty among black and white students, very similar kind of thing, 0.39 correlation coefficient. So these are very driven by these district-level characteristics. We take a multivariate approach, and so this is a pretty simple model here, right? On the outcome, we have these test score gaps. We put things in there like the average level of SES of the district, the racial differences in socioeconomic status at the district level, this measure of segregation, and 2 demographic variables. And with this parsimonious model, we can explain almost 2/3 of the variation at the metro level and nearly half of the variation at the school district level. So they're doing kind of a lot of work, even though there's not too much going on in the model. We take this exact same model, and then we add some measures of school quality, class size, relative class size differences, spending in the metropolitan area, relative spending differences, charter enrollment, and relative differences in charter enrollment. Keep the other variables in the model, and now the R-squared has gone up a trivial amount from 0.63 to 0.65 and 0.41 to 0.44. So we sort of take this to kind of confirm some of this Coleman hypothesis. So schools appear to have limited impact on test score gaps. But when we think about these non-test score academic domains, we know that schools have a great deal of discretion over these other kinds of outcomes. And so I was actually kind of fishing around for a theory that could help me conceptualize this view. And there's a nice paper by Emily Penner and Thad Domina and Andrew Penner in ASR last year, I think, where they kind of theorize about this notion of categorical inequality. So the idea is that schools are creating categories in strata because we have a stratified society. And so if you have a stratified society, you need some kind of stratified signaling in order to allocate individuals into these strata. So they say schools create a field for the construction and legitimation of social inequality. Schools play an important role in determining which positions specific individuals occupy, as well as in determining and legitimating the social distance between these positions. So schools are producing these categories. It's something that schools are doing. So they create them and X hypothesize they are going to be consequential for student well-being. So we're not thinking about all of the kinds of things that schools produce, but thinking of categories that are high stakes for students. And then that these categories that schools are producing are going to be directly produced by the school systems. In other words, if you took schools away, these types of categories would cease to exist. So they're really born out of the institutional infrastructure of schooling itself. So what I'm going to do is I'm going to introduce some candidate categories of categorical inequality. So these are variables that you can get from the CRDC. Suspension rate gaps, AP course taking gaps, special education classification gaps, IEP 504, as well as gifted and talented gaps at the district level. So we're going to calculate what percentage of the population are getting these services and take the logged ratio of that difference to get a gap at the district level. And in total, we're going to get about 1,700 school districts. So there's like 15,000 school districts in the United States. 1,700 still gives us 75% of the relevant population of interest. So that's just because of the great deal of segregation that exists in the US. So I'm just going to, in this talk here, present 3 stylized facts about categorical inequality. And so the first one is not going to be a big surprise to anyone, which is that these inequalities are quite large. So when you look at some of these different kinds of measures that you can get from the CRDC, we see that black students are 2.6 times more likely than white students to receive in-school suspension. They're 2.8 times more likely than white students to get an out-of-school suspension. They're 4 times more likely than white students to get multiple out-of-school suspensions. So there's really large gaps. Gifted and talented 3 times. AP course taking 2.2 times. And the special education issue is a little bit more nuanced, I think, than the data allow us to decompose. So we see that black students are receiving IEP 504 classification only 5% more times. And there's some recent work by Morgan and Farkas to suggest that maybe the issue with special needs is not overclassification, but underclassification, because some special needs services provide lots of resources for visual and auditory impairments, for example. Those are resource-rich classifications. And so we'll actually see here when, oh, I thought I had another slide. I don't. Oh, I hit it. Sorry. It's not there anymore. You can imagine there's another row here. And so basically what we can do in the model is we can kind of control for socioeconomic differences. So when you control for socioeconomic differences, the constant in this model can then sort of be interpreted as the average disproportionality in places that don't have any socioeconomic inequality. And basically the main thing here is that these shrink a little, but not by very much. Even conditional on SES differences, the multiple out-of-school suspension rate gap is still 3 times more likely. But the special needs classification does reverse. So using aggregate data, we can basically confirm what Morgan and Farkas found using their individual level data. So we see that the second stylized fact is that they are correlated with these kinds of district level characteristics. So what I'm going to do is I'm going to standardize these measures of categorical inequality as well as these other kinds of inputs. And so the factors that I'm using as predictors here are math, test score gaps, an income gap, a parent education gap, and this measure of segregation. So these are standardized dependent and independent variables. So a 1 standard deviation in increase in the math achievement gap is associated with a 0.64 standard deviation increase in the suspension rate gap. So this is a really powerful predictor. So the test score gaps at the district level are predicting the likelihood that you'll see these suspension rate gaps at a very high level. I think ironically, gifted and talented you could sort of think of as a kind of a quasi-academic indicator. Getting access to gifted and talented is should sort of correlate with academic preparedness. But the test score gaps are actually less correlated with gifted and talented gaps as they are compared to the suspension rate gaps. So even though these correlations are still pretty high, they're actually disciplinary disproportionality is really where these correlations are most strong. When you look at this other thing, special needs, you see correlations, but they're relatively modest. And then for AP course taking, you see standardized correlation coefficients that look a lot like gifted and talented. So these disciplinary disproportionality is really what's being driven by some of these background characteristics. And so the last piece is that the categorical inequality is cumulative. So because these things are correlated, what that means is we're going to find districts where there's a preponderance of inequality. So just kind of as a first pass, I think you can see this. So these are all the different gaps. ELA in math, in-school suspension, one suspension. Multiple suspensions, gifted, talented, SPED, AP class taking. And so these are just the top 10 districts in the US for each of these categories. And I've color-coded them because these are the districts that are repeated across multiple gaps. So this is Berkeley. Berkeley is number 1 and number 2, ELA in math test score gap in the United States. But it's also very large in-school suspension rate gaps. and has very large special needs classification gaps. Atlanta's on there for math and ELA and 2 disciplinary outcomes. And then you get a lot of these North Carolina districts which have some kind of university attached to them. They have large ELA and math gaps as well as these disciplinary rate gaps. So we see a little bit here that there is this kind of piling on happening. So if you'll allow me, what I'm going to try to do is simplify the structure a little bit. So we can sort of think of 3 inequality types: test scores, discipline, and access, or classification, you could call it. And so I'm going to take the 1,700 districts that we have in the sample and get the distribution and take the top quintile of districts for each of these gaps. So these are kind of the places that have the largest 20% of gaps in any one of these 8 variables. And then I'm just going to say, OK, you can have 1 gap in the top quintile of either of these test score gaps. You could have another in the discipline rate gap, and another in these access gaps. So in total, you can have up to 3 gaps in the top quintile. And you could have 0. And so what we find here is that there are 182 districts in the sample where basically either one of the test score gaps is a very large test score gap. There's a disciplinary gap that's also in the top quintile. And one of these classification gaps is also in the top quintile. And that corresponds to 17% of the black population in the United States. So in a little baby simulation thing that I did, if you just were to randomly generate gaps, so they're by construction not correlated with each other, the kind of number you would get is 140 districts with 3 gaps in the top quintile. So we're overstating it by 40 districts. And in the simulation, the percentage of the black population that would be in these sort of districts that have high degrees of accumulated disadvantage would be 8.5%. So we're doubling the number of black students in the United States that are in these districts that have high intensity inequality, doubling it. And so now we have these 3, 0, 1, 2, 3. And so you can do this multinomial logic kind of thing to see if you can sort of predict which places are going to be more likely to have multiple gaps. So these are marginal probabilities. On the x-axis is the percentiles of SES gaps, so parent income and parent education gaps, as well as this measure of segregation. So over here are these places that are in the 80th and 90th percentile of racial socioeconomic inequality. And over here are the places where there's not a whole lot of inequality. And so the probability of having 0 gaps in the top quintile goes down steeply and approaches 0 when you're in these places that have a lot of socioeconomic inequality. So you basically, over here, you're getting no gaps. Well, the probability of having 0 gaps goes to 0. The probability of having 1 gap kind of increases a little bit throughout the distribution, then starts to decline. Same for the 2 gaps, it kind of goes up. And then the probability of having 3 gaps in the top quintile increases to almost 50 to 70%. The standard errors are pretty large on this side at this part of the distribution. So just kind of get a sense of what these kinds of school districts are. These are places that are in the 80th and 90th percentile of parent income inequality, as well as school level exposures to poverty. And then they also have test score gaps, disciplinary gaps, and some kind of a classification gap also in the top quintile of the distribution. So these are really especially unequal places. But I don't want you to get the idea that background conditions are somehow deterministic of what's happening. So what we're having here is just this is a factor composite of these family income, parent education gaps, and segregation measures. So it's just a composite. 0 basically just means it's kind of the average level of racial inequality in the district. Over here is high degrees of inequality. And we're just plotting districts for each of these kinds of 0, 1, 2, or 3 income quintiles. And basically, first of all, if you kind of move your eye up vertically, there are a lot of districts over there that have average levels of socioeconomic inequality and still have 3 of these types of gaps in the top quintile. So these are places that have not much happening in terms of relative family income or neighborhood composition, but still quite a bit of inequality. And then there are also places over here that have a lot of socioeconomic inequality, but have many fewer of these school-based academic outcome gaps. So this is just to kind of show descriptively what the relationship looked like, but it's not to justify it in any way. So sort of like takeaway message here is I think that this notion of categorical inequality gives us a normative framework for evaluating school-produced inequality because it places the burden of justification on schools to explain why these things are taking place. So whereas if you're operating from this framework of the kind of Coleman framework, schools become the sort of neutral party. But because we're dealing with the kinds of outcomes that schools are producing directly, schools have to explain why these gaps are prevalent. And we see here that schools appear to be perpetuating background inequality via these channels of disciplinary and classification systems. And they don't have to be doing this because there's quite a bit of evidence that you can do things to actually reduce these kinds of inequalities. A recent paper in, I can't remember the journal, by Kanafua, they do an actual field experiment and do a brief empathy intervention for teachers. And they were able to halve the school suspension rates in the school district. And then we also know that as states have eliminated zero tolerance policies, suspension rate gaps and suspension rates as a whole have also decreased dramatically. So this is a policy tool. And in terms of some of these other kinds of things, there's an experiment by Card and Giuliano where they use a universal screening device to actually, instead of allowing students to try and use their parents to get into gifted and talented, they actually just have a universal screener. And this reduced the gifted and talented gap dramatically in the area that they were using this experiment. So there are these policy tools in place that can allow us to kind of move away from the categorical inequalities that schools are producing. And then I have some additional slides. Yeah, so thank you. That's it.